multiplying and adding 1?
So it's 2.
So we have to go 2 times 8 plus 1, so that's 17. Okay? So, for goodness sake, remember that the one that works first is the one that's physically closest to the number there. Okay? Right, now, just last things. I need to tell you the domain and range toolkit. Because there are 4 possible ways to work out a domain, and one of them is massively underused. Okay? So, the first one is called the natural domain. And this is most often used for algebra, and you just think, what screws the algebra up? Okay, so does anything screw that up? Can anything screw up? Can anything bad happen when you double and add 1? Nothing. Therefore the natural domain is all x. Yeah? Can anything screw this up? Negatives can. Therefore the natural domain is x greater than or equal to 0. Yeah? Can anything screw this up? Yes, 0. 1 divided by 0 is math error, yeah? So therefore what's the natural domain of that? Everything except 0. Okay, let's do a weirdo one. What can screw that up? 0 can certainly screw it up because then you get a square root of a negative number. Okay, so negative. So what will screw the square root of? Anything where this comes out negative. So I think that's anything which is less than 1. Is that right? But also we're dividing by a number, so we can't afford that for it to be 0 either.
Yeah.
Okay, so that's why I put that there. Okay, so therefore the natural domain is everything else.
So 1 would...
Yeah, there we go, that's why it's not in the domain. This is the screw up.
Right.
Yeah? So all of them, that's the screw up, that's the natural domain. That's the screw up, that's the natural domain. That's the screw up, that's the natural domain. You think what screws it up? The natural domain is everything else. Okay? You cool with that? Now, I'll talk to you about how to write these properly. Okay, so let's, what do we have? We had all x. We had x not equal to 0. We had, okay, let's, okay, let's talk about these. Do you know how to talk about all possible values of x?
Yeah.
There's a little funky symbol for it. What you do is you write curly brackets. Then you mention the letter you're going to use, x. Okay? Then you write a dot dot. And then you say, oh wait on, sorry, you don't do that. You write what type of number it is. The name for general numbers is this. You use this little funky symbol. And then you write after a dot dot if there's anything special about it, and there's nothing. So in fact that's the answer. Okay, so this one would be, I'm using the letter x. X is a general number, but it has to be not equal to 0. Yeah? X is a general number, and x has to be greater than 0. So that's how you write domains properly. Now do you know any of the other funky names for these? Do you know how to talk about the whole numbers? I'll tell you what's there. Yeah? So that's negative 3, negative 2, negative 1, 0, 1, 2, 3. Yeah? And do you know how to talk about the positive whole numbers? Yeah? That works? And do you know how to talk about the non-negative whole numbers? What are the non-negative wholes? Yeah? finally, there's another funky little one. It's called Q. Have you heard about Q? They're whole number fractions, but they don't come up very often. So like, 7, that counts. 3/7, that counts. Does anything not count as a whole number fraction? 2.5 counts. Why is that? Because it's 5/2. Does anything not count? Why wouldn't they count? 3 1/7, that's 22/7. That's cool.
But everything can be like multiplied.
Okay, I'll tell you. It's E. The number E doesn't count. Pi doesn't count. And surds from year 10 11, they don't count. Okay, they are not in the whole number fractions. You can prove that those numbers can't be written as whole number fractions no matter how hard you try. Okay? So what we just discussed then was item 1 of your domain toolkit. Now, item number 2 is restrictions in brackets. Oh yeah, what are we going to ask?
On page 4,
Yeah.
what's the difference between the positive holes and the non-negative holes? Is that the same thing?
Non-positive means you cut 0.
Oh, okay.
Yeah, you cool?
Yeah.
Oh, by the way, what's one where the natural domain is the whole numbers? Have you ever seen a symbol that can only cope with whole numbers? You learned it in Emma's dilemma. It's that. Remember that? It's when you go 5 times 4 times 3 times 2 times 1. That can only cope with whole numbers, and it needs to be non-negative whole numbers. Can't cope with -3. Yeah, but it can cope with 0. If you do that on a calculator, you get 1. If you do that on a calculator, you get 1. Do that on the calculator, you just get your normal business. You learned in your age. Yeah? So the natural domain of that is x dot dot. What type of a number are we talking about?